Welcome, pre-cal students, to the test number 2 review sheet. Let me go ahead and write that down for you. Test number 2 review sheet. As you can tell by my voice, this is not a video from last year. It's a video from right now in the present. So here is your review sheet. Let's go ahead and get started right away. Usually I have the problems cut and pasted. I'm just going to copy them quickly in front of you and then work the problems out. So here we go. Let's jump into this right away and let's get started. Page 580, we'll start off with, actually, this is not the entire review sheet. I apologize. There's a little bit more, and you guys know that. Let's type it up here real quick while we're at it. Page 617, numbers 2 through 14. Oh, no, evens. Alright, and so, there's the rest of the review sheet. Okay, we're going to start on page 580, problem 2a, and so here we go. Alright, problem 2a says to determine the exact values of the 6 trig functions, and the problem looks like this. We have our coordinate plane like this. Here's our terminal side of our angle, and the angle starts from here and goes to here. Now we're going to call that angle theta, okay? Now remember, I'm trying to find the sine, cosine, tangent, cosecant, secant, cotangent of this angle right here, okay? But that's the exact same thing as the reference angle right here. Okay, so we're going to call this angle right in here theta primed. Okay, so instead of finding sine, cosine, instead of finding the 6 trig functions of this angle here, we're going to use this angle here, but we're going to remember the signs are negative, negative, positive. Okay, so here we go. We're over negative 12 and down 5. If you'll look in the book, you'll see that. So 12. I really don't care about the signs, and then 5, okay? So using Pythagorean's theorem, we would have what? Doing this in my head, 144 plus 25 will be 169, and the square root of 169 is 13. So the hypotenuse is 13. So here we go. The sine of theta is negative, first of all, and it would be opposite over hypotenuse, 5/13. So the inverse cosecant of theta would be negative 13/5. Alright, the cosine of theta would be adjacent over hypotenuse, it's negative, so negative 12/13. The inverse of cosine is secant, and so the secant of theta is negative 13/12. The tangent of theta is opposite over adjacent 5/12, and it is positive. So cotangent would be the inverse of that. So cotangent of theta would be 12/5. Okay, pretty cut and dried. Okay, all right, moving on to the next number, which is 10. Number 10. The directions for 10 say the point is on the terminal side of an angle in standard position. Determine the values of the 6 trig functions. So here's the ordered pair they give us: 1/2, comma, negative 12/7. There we go. Okay, so let's go ahead and plot that. It's going to be in the 4th quadrant. So we're going positive 1/2 and then down 12/7. And it does not need to be drawn to scale. Okay, that's not necessary at all. So here we go. So theta is going from here to here. Okay, there's the angle we're dealing with. Well, instead of finding the 6 trig functions of theta, let's just find the reference angle. We'll call it theta primed. And remember, the signs here are negative, positive, negative. And we're just going to find the sine, cosine, tangent, cosecant, secant, cotangent of this angle right here. Okay, so I have a length here of 1/2, and then I go down 12/7. Okay, so let's quickly find the Pythagoreans. Let's find the missing hypotenuse. I would have 1/2 squared, that's 1/4, plus 12/7 squared, that's 144 over 49, equals hypotenuse squared. So I did leg squared plus leg squared equals hypotenuse squared to find the hypotenuse. So with my calculator, I have 1/4 plus 144/49, and that's going to give me 625 196 equals hypotenuse squared. Alright. Now if I take the square root of that, actually 625 is a perfect square and 196 is a perfect square. So the square root of 625 is 25. The square root of 196 is 14. So my hypotenuse is 25 over 14. Now, these are going to be some really pain in the neck numbers to use. So let's go back to geometry last year and think this through. Remember how similar triangles have the same angles but proportional sides. In other words, this angle here, or that triangle there, and that triangle there, as long as all three angles were the same, they're proportional, okay? So as long as this angle right here doesn't change, I can make the fraction a different size and not have to use these fractions. Let me show you what I mean. I have denominators of 2, 7, and 14, correct? So think about this. Come on, guys. If I multiply all of my sides by 14, it will eliminate my fractions because a common denominator for 2, 7, and 14 is 14. So why would I want to find the sine, cosine, and tangent using all these fractions when I can take each side and multiply it by 4? That gives me a bigger triangle, but the angle doesn't change. Okay, so here we go. Multiply this by 14 and you get 7. Multiply this by 14 and you get 24. Multiply this by 14 and you get 25. Now that's a lot nicer. Okay, so here we go. Sine of theta equals negative, because it's negative, opposite over hypotenuse, 24 over 25. The inverse of that, cosecant of theta equals negative 25 over 24. Cosine of theta would be positive because we have a positive sign here. Cosine would be adjacent over hypotenuse. So the inverse secant would be 25 over 7. Alright. The tangent of theta would be opposite over adjacent, 24 over 7. But don't forget to check your sign. Tangent is negative in this quadrant. Okay. And so cotangent would be the inverse, which is negative 7 over 24. There we go. Okay. Alright, let me check my tangent real quick. Opposite over adjacent. Yeah, that's right. Okay, guys, moving on to the next problem, which is number 20. Let's take a look at number 20. Alright, number 20 is, they tell us that cosecant of theta is 4. So they tell us that. And cotangent of theta is negative. Cotangent of theta is less than 0, which means it's negative. So I'm looking for a quadrant in which cosecant is positive, because I have a positive 4 here, and cotangent is negative. Now remember, the inverse of cosecant is sine. So where is sine positive? Here and here. Alright, so quadrant 1 and 2. Cotangent is the inverse of tangent. Which one of these two quadrants has tangent negative? Well, not here. Tangent's positive. Over here, tangent's negative. The signs go like that. So we are going to be in this quadrant here. Okay? So students, hopefully you see how I found what quadrant we're in. By this information here, I know what quadrant I'm in. So that means my terminal side is right here. My terminal side is right here. I'm finding the 6 trig values for this angle right here. But remember, instead of using that angle there, I can use this angle here as long as I remember that the signs are positive, negative, negative. Now cosecant of theta is 4 over 1. Cosecant is the inverse of sine, so 4 is your hypotenuse and 1 is your opposite side. So opposite is 1, hypotenuse is 4. Let's see, 16, 1, 15. So the leg right here would be the square root of 15. Okay, there we go. Let's jump right into this, okay? So the sine of theta would be positive. It would be opposite over hypotenuse, 1/4. So the cosecant would be 4, and that's what we have right here. The cosine of theta would be negative, and it would be adjacent over hypotenuse, so square root of 15 over 4, okay? So the reciprocal, the inverse of that would be the secant of theta is negative 4 over square root of 15, and of course we're going to rationalize that and make it negative 4 square root of 15 over 15, okay? Now tangent of theta would be opposite over adjacent, so 1 over square root of 15, alright? So then cotangent, will be negative, sorry about that. So the cotangent of theta, square root of 15. The cotangent of theta would be negative square root of 15 over 1. Now, of course, we got to rationalize this, so we'd really have negative square root of 15 over 15. And there we go, guys. Doing well, moving right along. Next is number 28. Alright, number 28 says, the terminal side of theta lies on the given line that's given to you. Find the values of the six-trig function. I'm pretty sure I gave this problem to you here on a test, but we'll go ahead and do it again. Okay, 4x plus 3y equals 0. We're in quadrant 4. Yes, we did this in the test already, but we'll do it again, okay? So we know we're in quadrant 4, coming out like this. And I know that 0, 0 is on the line because if I put a 0 in for x and a 0 in for y, I get out 0. So that's definitely one of the ordered pairs that satisfies the equation. Now, if I can just find another point on this line that I can draw my triangle and be all set, well, you can put any number in for x that you want to, but I would encourage you to put a number in for x, so that when you solve for y, you do not get out a fraction. For example, I'm going to put 3 in for x, okay? Positive 3. Well, 4 times 3 is 12. Got it? 4 times 3 is 12. Bring your 12 over and make it a negative 12. Divide both sides by 3, and y equals negative 4. So there we go. That ordered pair satisfies this equation. And since it satisfies this equation, that means this ordered pair right here lies on this line. So I'm over 3 and down 4. There we go. So 3, 4. That makes the hypotenuse 5. The sine sequence is negative, positive, negative. So the sine of theta is negative. Opposite over hypotenuse 4/5. So the cosecant would be negative 5/4. The cosine of theta would be positive. It would be adjacent over hypotenuse 3/5. So the inverse of that is secant. Secant of theta would be 5/3. Tangent of theta would be negative because the negative sign. Opposite over adjacent, so negative 4/3. So the cotangent of theta would be negative 3/4. Okay. All right. Moving on to numbers 30 through 36 evens. 30 through 36 evens. So here we go. Number 30. We're simply going to use our calculators. These are all quadrant angles. So we're going to find the cosine of 3 pi over 2. And you're welcome to make sure your calculator is in degrees. And you can, if you want to, you can make sure your calculator is in radians, and you would hit cosine. And then hit 3, then your pi button, then divide it by 2, and then hit enter. For me, I prefer being in degrees. And just very quickly converting this over to degrees. So for me, I'm going to use 270 degrees. So 3 pi over 2 is 270 degrees. The cosine of 270 degrees is 0. So the answer is 0. Number 32. Number 32 is secant So go ahead and take the cosine of 270. Then whatever you get, we're gonna reciprocate it. So the cosine of 270 is 0. So the cosine of 270 is 0. So if you flip that or find the reciprocal, you will get undefined. Remember, the reciprocal of undefined is 0, and the reciprocal of 0 is undefined. Okay? So the secant of 270 is undefined. Alright, number 34. Tangent of pi. Alright, tangent of pi is the same thing as the tangent of 180. Alright? So the tangent of 180 is 0. That was pretty easy, cut and dried. 0. Alright, number 36. Cosecant of pi. Now, our calculator does not do cosecant, so we're going to find the inverse. And then whatever we get, we're going to flip it and put it over here. So the sine of pi, the inverse of cosecant is sine. So the sine of pi is, or the sine of 180 is 0. So the inverse or the reciprocal of 0 is undefined. So the cosecant of pi is undefined. Okay? Not too bad, guys. Really just pretty much calculator problems and remembering which trig functions are inverses of each other, and then also remembering that that the inverse of undefined is 0 and the inverse of 0 is undefined. Okay, moving on to numbers 52 through 58 even. 52 through 58 even. And here we go. We're going to evaluate the sine, cosine, and tangent of the angle without using a calculator. So 52 through 58 evens. Here we go. Alright, number 52. They want us to find the sine, cosine, and tangent of 300. Now, look guys, we have special triangles. I'm going to go ahead and draw those off to the side here. Okay? Call this a 45, 45, 90 triangle. 1, 1, square root of 2. That's so easy, guys. Just memorize those, okay? We have a 30, 60, 90 triangle, okay? This is 2, this is 1, this is square root of 3. Now they want us to deal with 300 degrees without using a calculator, okay? Let's do this, draw that. 300 degrees. Well, I don't know the sine, cosine, and tangent of 300, but the reference angle for 300 is 60. So instead of finding the sine, cosine, and tangent of 300, I'm going to use 60 instead, as long as I remember the signs are negative, positive, negative. So here we go. The sine of 60 equals negative answer. What's the sine of 60? Opposite over hypotenuse, square root of 3 over 2. Cosine of 60 is positive. That would be adjacent over hypotenuse, 1/2. Tangent of 60 would be negative. Opposite over adjacent, square root of 3 over 1, or just square root of 3. Just like that, we're finished, okay? Alright, moving on to number 54. Is the sine, cosine, and tangent of negative 405, okay? So we're going to find the sine, cosine, and tangent of negative 405 degrees without using a calculator. Okay, so here we go. I have no idea what that answer is, but I think I can find a reference angle. Go around 360. Now notice I went this way because it's a negative 405, okay? Normally you would start here and go like this, okay? But it's a negative angle, so we start here and we go this direction, alright? So 405 degrees, one rotation is 360, plus 45 more, I stop right there. So that means the reference angle, this little angle here, would be 45 degrees. So instead of using 405, I'm going to use 45. And it doesn't matter if 45 is positive or negative. All that matters is I know what quadrant I'm in. The signs are negative, positive, negative. So the sine of 45 is opposite over hypotenuse, negative 1 over over square root of 2. So we're going to rationalize that and make it square root of 2 over 2. Alright, cosine of 45. Let's see, cosine would be adjacent over hypotenuse, positive. So 1 over square root of 2. Rationalized is the same thing, square root of 2 over 2. And then tangent is opposite over adjacent, 1 over 1. Tangent is negative, 1 over 1 is 1. So there's your answer. Okay, moving on to number 56, students. Number 56. We're going to find the sine, cosine, and tangent of negative. Did I do the wrong numbers, guys? I hope not. Yep, I did. Of course I did. Okay. Well, what can I say? Except that, well, I did 52. I just did it 405. I labeled it the wrong number. Now I'm going to do 54, okay? So we got a little extra number in there. So the problem I just did, I called it number 50. I think I called it 54. That was really number 52, okay? Now, so 52 is done. Now number 54. Negative 840. So we're looking at the sine, cosine, and tangent of negative 840. Well, let's find a reference angle. 360. Go around again. 720. We want to go to 840. That's 120 more degrees. So go around once is 360. Go around again is 720. And then go 120 degrees. If you go 120, you're left over with how much in here? 60. So the reference angle you're going to use is 60. However, don't forget here the signs are negative, negative, positive. So the sine of 60, the cosine of 60, and the tangent of 60. Just don't forget sine is negative, cosine's negative, tangent is positive. So here we go. Sine of 60, opposite over hypotenuse, 1/2. Cosine of 60, adjacent over adjacent over hypotenuse, square root of 3 over 2. And actually, guys, you know what? Hold on. I think I'm trying to go too fast. Let's start over. Sine of 60, opposite over hypotenuse, square root of 3 over 2. Sorry about that. Cosine of 60, adjacent over hypotenuse, 1/2. Tangent of 60, opposite over adjacent, square root of 3 over 1. And there we go. Okay, not too difficult. Okay, moving on to number 56. Okay, students, moving on to number 56. Number 56, we're dealing with the sine, cosine, and tangent of 3 pi over 4. Okay, now, first of all, let's leave it in radians just for a second, okay? Remember, from here to here is 1 whole pi. So, if I go from 3/4 from here to here, I'm left with pi over 4 inside here. And pi over 4 is 45 degrees. That's one way to do it. Probably an easier way, to be honest with you, is to say 3 pi over 4 is the same thing that equals 135 degrees. So I'm going to go from here to here. And then I'm left over with 45 degrees right here on the inside. So the sine, cosine, and tangent of 135 is the same thing as the sine, cosine, and tangent of 45, as long as I remember my signs here are positive, negative, negative, okay? And so we have positive, negative, negative. Sine of 45, opposite over hypotenuse, 1 over square root of 2, or square root of 2 over 2. Cosine of 45, adjacent over hypotenuse, 1 over square root of 2, which is the same thing as square root of 2 over 2. Tangent of 45 is opposite over adjacent, 1 over 1, which is 1. So pretty simple, guys. Again, moving on. Number 58. Number 58. We're going to find the sine, cosine, and tangent of negative 4 pi over 3, which is the same thing as negative 240 degrees. Okay, so negative 240, that's 180 plus 60 more. So if I went 60 more past this point here, 180 plus 60 more, then the reference angle here is 60. So I'm simply finding the sine, cosine, and tangent of 60, which is the same thing as negative 240, as long as I remember the signs are positive, negative, negative. Sine of 60, opposite over hypotenuse. Cosine of 60, adjacent over hypotenuse. Tangent of 60, opposite over adjacent. Square root of 3 over 1, or just square root of 3. Of course, with the appropriate signs. That's it, guys. Not too bad. Alright, moving on to numbers 64 through 78, the evens. 64 through 78, the evens. And so, here we go. And actually, I have a feeling we might need those triangles again. I'm not sure. But just in case, I'm going to save those. Or at least I'm going to try to. Alright, number 64. The directions say to find the trig value in the specified quadrant. So they're telling us cotangent of theta equals negative 3. We're in quadrant 2. Find the sine of theta. Alright, so we're in quadrant 2. Right here. Cotangent is negative 3. So the sine sequence is positive, negative, negative. So when I go to find the sine of theta, I know my answer will be positive because of this right here. Okay. Cotangent is adjacent over hypotenuse. So this is my adjacent side. This is my opposite side. So adjacent would be 3. Opposite would be 1. So the hypotenuse would be 1, 9, square root of 10. Okay, so now that my triangle's filled in, the sine of theta is opposite over hypotenuse, 1 over square root of 10. And of course, 1 over square root of 10 is square root of 10 over 10. There we go. Moving on to number 66. Alright, let's see here. 66 is the same type of problem, and the information they're giving us is cosecant of theta equals negative 2. We're in quadrant 4, and they want us to find the cotangent of theta. Alright, these are really pretty simple, guys, not too difficult at all. We go to quadrant 4, right here. The sine sequence is negative, positive, negative, so cotangent is going to be negative because of my negative sign right here. Cosecant is negative 2 over 1. Cosecant is the inverse of sine. Sine is opposite over hypotenuse, so this would be hypotenuse over opposite. So your hypotenuse is 2. Your opposite is 1. So the other leg would be square root of 3. Alright. So here we go. Cotangent would be tangent's opposite over adjacent. So cotangent would be adjacent over opposite. So square root of 3 over 1, which is square root of 3. Okay, moving on to number 68. Information they give us is secant of theta equals negative 9/4. We are in quadrant 3, and they want us to find the tangent of theta. So we're in quadrant 3, right here. Secant is the inverse of cosine, so hypotenuse over adjacent. The hypotenuse would be 9, the adjacent would be 4. The other leg would be Pythagorean's theorem. 81 minus 16 would be what? 65. So the square root of 65. this one was on your test, I believe. We just took, or a quiz, either way. Alright, so the sine sequence is negative, negative, positive, so tangent's going to be positive. Tangent of theta is opposite over adjacent, so square root of 65 over 4. Alright, moving on. We're going to 78. Okay, moving on now to number 70. Number 70. Use a calculator to evaluate the trig function to 4 decimal places. Okay, these should be pretty simple. Number 70, secant of 235. Your calculator does not have a secant button, so the inverse of secant is cosine. We're going to find the cosine of 235. So on your screen, type in the cosine of 235. Make sure you're in degrees. Hit enter, and you're going to get this right here. Negative 0.5735764364. Now, without pushing anything else, go to the left side of your calculator and push this button right here, okay? When you do, this is going to pop up on your screen. Then hit enter, and you'll get the correct answer, which is negative 1.7434. What you did by pushing this button here is it took this right here over 1 and it flipped it, which is this right here. So x to the negative 1 gives you the inverse, okay? Alright, moving on to number 72. Number 72. Alright, the cosecant of negative 320. Cosecant of negative 320. Now, the inverse of cosecant is sine. So on my calculator, I'm going to type in sine, and then I'm going to type in negative 320. I hit enter and I get this 0.6427876.097. Now, listen to me, students. If you don't want to use this button right here, if I confused you with that button there, that's fine. Just realize this whole thing is over 1, so flip it. So with your calculator, type in 1 divided by this whole thing right here, and you'll get the right answer. To me, it's just easier to leave this on the screen. Now hit my x to the negative 1 button, and it says, okay, take this answer here and invert it. Hit enter, and you'll get the correct answer, which is 1.5557. Moving on to number 74. Number 74. Okay, number 74 is cotangent of 1.35. Now, please notice there's no radians. Okay, excuse me, there's no degree symbol here, so we're dealing with radians. Now, normally, I don't mind converting radians over to degrees, because they usually have pi, like 7 pi over 11. It's such a pain to type that into your calculator. But here, this is a nice decimal, so for me, I'm going to do this. I'm going to go into my mode, top left button, second column from the left, top button. I'm going to push mode, go down to radians, hit enter, and then hit second quit. Now I'm in the radian mode, so my calculator does not do cotangent, so I'm going to type in the inverse, tangent of 1.35. Now if you type that in correctly, you're going to get 4.455222176. Now you want to flip that or invert it to get the cotangent, so hit x to the negative 1, and this will pop up, and that will give you 0.224455, so 0.2245 rounded correctly. Okay, alright, moving on to number 76. Number 76. The tangent of 11 pi over 9. Now, since I'm already in radians, I'm just going to type that into my calculator. I'm going to type in tangent, then type 11, then the pi button, then divided by 9, then hit enter. So tangent 11 pi divided by 9, enter, and you'll get this for your answer. 0.8391 if you round correctly. Okay, moving on to number 78. That was pretty simple because you didn't have to do any inverses or anything like that. So, alright, number 78, sine of 0.65. Now again, notice there's no degree symbol, so we are in radians. Since my calculator's still in radians, I'm just going to hit sine and then 0.65. And if you type that in correctly, you're going to get 0.6052 if you round correctly. Okay, students, I hope that makes sense. Moving on now to numbers 82 and 84. 82 and 84. Okay, the directions for 82 say find two exact solutions for each equation. Do not use a calculator. So, first of all, number 82. They want me to find the secant of, secant theta equals 2. Okay, now, look guys, we should have a pretty good chart made up for you. What I'm going to do is this. We're not really familiar with secant, okay? So I'm going to use, instead of using the secant theta equals 2, I'm going to use this instead. What's the inverse of secant? Cosine of theta equals 1/2. Now you should know what that angle is. If you don't, think of a triangle that has a 1 and a 2 in it. Remember, your 30, 60, 90 triangles, they have a 1 and a 2 in them. You have a 2 here, a 1 here, and a square root of 3 here, okay? Now, what angle, when you take the cosine of it, gives you 1/2? Well, let's see. 30, would that work? No. Let's see. 60 would. What's the cosine of 60? Adjacent over hypotenuse. So theta is 60. But now here's the problem. Watch this. They want two answers. So the only way to get two answers is to think of, where is cosine positive? The cosine of theta is a positive 1/2. Well, cosine is positive here. Cosine is also positive here. So I know my reference angle is 60. That's easy. So I know one answer is from here to here is 60. The other answer would start from here and go all the way to the hypotenuse. If the reference angle is 60, then the angle that goes with the reference angle of 60 is 300 degrees. And now if you want to check your answers and type in the cosine of 60, you'll get 0.5. Then type in the cosine of 300, you'll get 0.5. But remember, your calculator was in radians, so make sure you switch it over to degrees before you do that. Okay. All right. Number 84 is next. Let's take a look at number 84. All right. Here we go. Sine of theta equals square root of 3 over 2. Actually, hold on 1 second here. I just saw that 82 does have a part B. Let's do that part B. We need to, guys. Alright, now 82 is, watch this carefully please, 82 part B is secant of theta equals -2. Well guys, the only thing that's changed is the sign. We still know that the reference angle is going to be 60. I mean, secant of 60 is 2. Type it in your calculator if you want to. Just make sure that you get into the proper mode. But if you type in cosine of 2 and then invert it, you'll get, if you take the cosine of 60 and then invert that, you will get 2. So the only thing that's changed is the negative sign. So the only thing that's changed is what quadrant we're in. Okay? So the quadrant we're in now is the two quadrants we're secant is negative here and here. So now I draw my two triangles here, put a 60 here and a 60 here. So one answer will start here and go to the hypotenuse, 120 degrees. Then one answer starts here and goes to the hypotenuse, So 180 plus 60 more. Stop at the hypotenuse. So 240. So there you go. There's your two answers. 120 and 240. Let's try that again on number 84, because on number 84 we have the same thing, an A and a B, in which the only difference between A and B is the signs. Okay, so 84, we're going to try to find theta so that we get a positive square root of 3 over 2. And then we're going to try to find theta so that we get out a negative square root of 3 over 2. So which triangle has a square root of 3 in it? Once again, it's my 30, 60, 90 triangle. This is 30, this is 60, this is 2, this is 1, square root of 3. So let's see, 60 would be my angle because the sine of 60 is opposite over hypotenuse. So here we go. My angle is going to be 60. Where is sine positive? Here and here. So put a 60 here and a 60 here. So one answer is 60 and the other answer goes to here. That would be 120. So your two answers will be 60 and 120. Now, how about the negative square root of 3 over 2? Okay, where is sine negative at? Quadrant 3 and quadrant 4. So put a 60 here and a 60 here. So one answer would be 180 plus 60, 240. And the other answer would start here, go all the way to the hypotenuse, 300 degrees. Okay, so there we go, guys. Back this up and watch this again if you need to. These can be pretty confusing, so make sure you understand these. Alright, moving on to 90 and 92. 90 and 92. The directions for 90 and 92 simply say to use a calculator to approximate two values, and they want your answer to be in radians. Alright, so number 90 is tangent of theta equals 3.262. So first of all, we've got to find our reference angle. So with my calculator, I'm going to simply hit secant tangent because I'm missing an angle, and then type in 3.262, and I'm going to get the angle of 72.9. I'm going to put 73 degrees. I think they said to round to two decimal places. I'm not going to do that, so my little reference angle here is 73 degrees. So tangent is positive here, and tangent is positive here. So put a 73 here and put a 73 here. One answer is 73 degrees, and the other answer goes to 180 plus 73 more. So what would that be? 253. So there's your two answers, 253 degrees and 73 degrees. Now let's take a look at number 92. Cosecant of theta is negative 6.125. Okay, now here we go. We got to find that reference angle. Now please listen to me. I would never worry about the negative sign when you're trying to use your calculator. Please don't do that, students. All that negative sign tells us is that we're going to be in quadrants 3 and 4, because the inverse of cosecant is sine, and sine is negative here, and sine is negative here. Other than that, please drop this negative sign. Just don't worry about it, okay? Trust me. Once you've established your quadrants, forget that negative sign. It's really in the way. Now, remember, the inverse of, first of all, we're missing an angle, correct? So since we're missing an angle, we're going to use our inverse button. The problem is on your calculator, there is no inverse cosecant. For example, if this said sine right here, then on my calculator, I would just hit inverse sine, and this would pop up, and then type this in. But I don't have a cosecant button, so we're going to have to use some identities here. remember, cosecant of theta equals, and I know how to do this. I'm trying to think of the easiest way to explain this too, so hold on a second. I'm going to say sine equals 1 over cosecant, correct? Isn't that correct? Sure it is. Now, what is cosecant of theta equal? This right here. So I'm going to go ahead and put that in place of cosecant theta. And again, I'm not worried about the negative sign. I don't care about the negative sign. So there we go. Alright, so what I'm going to type into my calculator is, to find theta, I'm going to type in second sine, and then 1 divided by 6.125. Hit enter, and you'll get 9.39 degrees. I'm going to put 9.4. So this little angle right here is 9.4. So I put a 9.4 here, and a 9.4 here. Go from here to 180 plus 9 more is 189.4. Here I go all the way around. I don't quite go to 360, so I take 360 minus 9.4, and I get 350.6. These are good problems, guys. They're making you think, okay? Back it up and watch it again if you need to. Alright, lastly, we're looking at numbers, or lastly on this page, we're looking at numbers 98 and 100. So let's see. Now they want us to give our answer in radians, so we're still doing the exact same thing. Only they want you to give your answer in radians. Now I'm going to leave everything in degrees, find my answer, and then convert them over to radians, okay? So number 98 is cotangent of theta. Equals 5.671. Now, first thing you want to do is find your reference angle, that little angle right here. Unfortunately, we cannot type into our calculator cotangent of -1 because our calculator does not do cotangent. Got it? So here's what we're going to do. We're going to say tangent, that's the inverse of cotangent, equals 1 over cotangent. That's a true statement. And then right here for cotangent of theta, we're going to put 5.671. So now I'm looking for an angle. I'm going to hit second tangent on my calculator, and then 1 divided by 5.671, and get 10.00048692 degrees. So 10 degrees. So my reference angle is 10 degrees. Now I'm trying, so I'll put a little 10 right here. Now I'm trying to find two answers in which cotangent of my angle right here gives me a positive answer. Well, tangent is positive here, and tangent is positive here, and tangent is the inverse of cotangent. So put 10 degrees here, put 10 degrees here. So one answer is 10 degrees. The other answer is 180 plus 10 more 190. However, that's not sufficient. They want us to convert it to radians, so we take 10 degrees times pi over 180. And if you do that correctly and get out a decimal, you're going to get 0.17 is one answer. 0.17453. Now take 190 times pi over 180, and we're going to get 3.32 if you round correctly. 3.32. So there's your two answers in radians. So really nothing's different. I found everything in degrees and then converted it over to radians. Alright, one more problem on this page, number 100, and it is cosine of theta. Cosine of theta equals negative 0.3214. Now, remember students, forget the negative sign. Establish your quadrants and forget the negative sign. Cosine is negative here. Cosine is negative here. There. Forget the negative sign now. Now we're trying to find this little angle right here. So we're going to have to hit second cosine because you're missing an angle. So second cosine. And then type in 0.3214. Enter. And you're going to get 71 degrees. So I'll put a 71 here and a 71 here. So one answer goes from here to here. That would be 109 degrees. and then one answer goes from here to here. So 180 plus 71, 251 degrees. Alright, so there we go. Now, we're going to convert 180 to radians by multiplying by pi over 180. Convert 251 into radians by multiplying by pi over 180. So here we go. 109 times pi divided by 180 gives me 1.90. So there's one answer. And then 251 times pi divided by 180 gives me 4.38 for an answer. And there we go. Okay, guys. So really not too difficult at all. Okay. All right. Moving on now to the special or the solving of right triangles. All right. Let's take a look now, students, at numbers 2 through 14, the evens on page 617, solving right triangles. All right. Number 2. They give us capital B is 54 degrees. I'm going to go ahead and draw a triangle we can use from here on out over here off to the side. I think C is, you see your right angle, and we're going to put B up here, A here, so little a here, little b here, and little c here. Okay, they're going to give us capital B is 54 degrees, and little c is 15. Okay, so if I know that this is 54 degrees right here, okay, this is my right angle here, then angle A would have to be let's see, 36 degrees. Alright, 54 plus 36 plus 90 is 180. Okay, now let's find side B, I guess would be fine. So we're going to find side B. This right here is 15. So I'm going to find side B. I could find side A first if I chose to. It doesn't matter. I'm just choosing side B. So I'm trying to find side B. I know this side here. I'm using this angle here. So this is opposite and hypotenuse. So sine is going to help me. Sine of 54 degrees equals opposite over hypotenuse. Multiply both sides by 15. 15 sine of 54 degrees equals B. Multiply both sides by 15. Multiply this side by 15. The 15's cancel. Multiply this side by 15 over here. Okay, so 15 sine of 54 equals 12.1. So B equals 12.1. You are welcome to use Pythagorean's theorem if you want to find the last side. I'm actually not going to. I'm going to use cosine of 54. Cosine of 54 equals adjacent over hypotenuse. Multiply both sides by 15, and 15 cosine 54 equals A. I think that's a little faster than using Pythagorean's theorem. 8.81, so we'll say 8.1. And there we go. Okay, so we've solved that right triangle, and here we are on to the next problem, number 4. Alright, and here's our triangle right here. And here we go. They tell us that angle A is 8.4 degrees. They tell us that side A is 40.5. So we're not doing too bad. Let's quickly find this missing angle here, angle B. So angle B would equal, let's see, 81.6. If you put 81.6 here, add up all three angles, you will get 180 degrees. So 81.6 degrees. Now we got to find side B and side C. Doesn't matter which one you find first. I'm going to use this angle here, use this side here, and solve for B. I just chose to do that. So tangent of 8.4. Now I use tangent because I have opposite and adjacent. So tangent of 8.4 equals opposite over adjacent, which is B. Now your denominator Here's B, so multiply both sides by B. So B tangent 8.4 equals 40.5. Then divide both sides by tangent. So B equals 40.5 divided by tangent of 8.4. So here we go. I'm going to type in 40.5 divided by, I'm going to put tangent of 8.4. And that will give me something that probably is not correct. Yeah, I think it is correct because I didn't draw my triangle to scale. It's going to be like this, and then like that. If I drew it to scale, it's going to be almost a right angle. Up here it's 81 degrees. So like this, and this angle right here is going to be really small. I'm getting 274 for B. But if you draw it to scale, that's about right. This much is 40. So 40, 80. I mean, it's not perfect, but yes, 274 is reasonable. So B equals 274. Now let's find side C right here. And so I'm going to use the same angle again. I'm going to use opposite and hypotenuse. Opposite and hypotenuse. That's going to be sine. Now you could do this other ways using other trig functions, okay? Sine of 8.4 equals opposite over hypotenuse. Multiply both sides by C. So C sine of 8.4 equals 40.5. Now divide both sides by sine. So C equals 40.5 divided by sine of 8.4. So 40.5 divided by sine of 8.4 would give you 277. And that makes sense because your hypotenuse always has to be the longest side in a right triangle. Okay, moving on to number 6. Number 6. The information would be A equals 25. Here's my triangle right here. A equals 25. And C equals 35. So quickly I can use Pythagorean's theorem to find the missing side. If I do that, I'm going to get, let's see here. Square one leg and square another leg and square the hypotenuse. We'd be left with, let's see, 35 squared minus 25 squared would give us 600, and the square root of 600 would be 24.5. So this missing side is 24.5. Now, I've got to find one of these angles. I'm going to use these two sides right here. I'm going to find angle B. So I'm going to say that based on this angle here, I've got adjacent and hypotenuse. That's cosine. So cosine of angle B equals adjacent over hypotenuse. I'm looking for an angle, so secant cosine, and then 25 divided by 35 gives me 44.4. Now, if this angle here is 44.4, then this angle down here has to be 45.6. And there we go. I've solved the triangle. Not too bad. Alright, moving on to number 8. Number 8. We have our triangle here. Side B is 1.32. And side C is 9.45. So Pythagorean's theorem, find the missing side. Leg squared plus leg squared equals hypotenuse squared. So with my calculator here, 9.45 squared minus 1.32 squared equals, then take the square root of that, and I will get 9.36. So this side over here is 9.36 by using Pythagorean's theorem. Now, because these are my two given sides, I'm going to use those. I just feel like doing it that way. This is angle A, so adjacent and hypotenuse. So cosine of angle A equals adjacent over hypotenuse. I am looking for an angle, so I'm going to use secant cosine. So with my calculator, secant cosine, and then 1.32 divided by 9.45. Enter 81.9. I'm just going to call this 82 degrees. So if that's 82 degrees, then this has to be 8 degrees up here. So there we go. Right triangle totally solved. Alright, let's take a look at number 10. Number 10. Alright, number 10. Capital B is 65. I'm going to convert that to decimals, guys. 12 divided by 60 is 0.2. So 12.2 degrees. And the side they give me is C, 430.5. Now I can quickly find this missing angle here by adding up all these angles. They should add up to 180. So this angle here has to be 77.8. Alright, now it doesn't matter which side I solve for first. I'm going to solve for A because I feel like it. They gave me this at the beginning. They gave me this at the beginning. I'm looking for this. So that would be adjacent and hypotenuse. So the cosine of 12.2 equals adjacent over hypotenuse. Multiply both sides by 430.5, so 430.5 cosine of 12.2 equals A. So now take in 430.5 cosine of 12.2, and I will get 420.78, or just 420.8. So this side right here is 420.8. Now I could use Pythagorean's theorem, but I'm not going to. Instead, I'm going to change colors here. They gave that to me. This was given to me. I'm looking for this right here, okay? So I have opposite over hypotenuse, that's sine. So sine of 12.2 equals opposite, which is letter B, opposite over hypotenuse, 430.5. Multiply both sides by 430.5. And then with my calculator, type in 430.5 and then sine of 12.2, and I will get 90.97, so 91. So the length here is 91. Okay, so really not too bad. Alright, let's move on now to number 12. Alright, number 12, students, here we go. They give us an isosceles triangle like this. This is theta, this is theta, this is side B. For number 12, they tell us theta is 18 degrees. So for right here, I'm going to put 18 degrees for this angle right here, okay? And they tell us that B is 10. They want us to find the altitude. So what I have to do is draw a line right down the middle here. And this line will cut this side in half because I have an isosceles triangle. So it says for 12, B is 10. So if this whole side here is 10, then that means this side right here is 5. So I have a right triangle that looks like this. Here's my right angle. This is 18 degrees, and this is 5. And they want me to find this altitude right here. We'll call it X. Well, guys, it's easy. Opposite and adjacent. So the sine, it's so easy I messed up. The cosine of 18 equals actually I messed up again. May as well make this really good. We're dealing with opposite and adjacent. So the tangent of 18 degrees equals opposite over adjacent. Multiply both sides by 5, and we have 5 tangent of 18 equals X. So with my calculator, 5 tangent of 18 equals 1.62. So there's the altitude, 1.62. Not too shabby. Alright, let's take a look at number 14. Number 14. Number 14 is a carbon copy of the last problem. If you'll look in your books, they tell us theta is 27, so put a 27 here. They tell you the whole length from here to here across is 11, and they want us to find the altitude. So I drop an altitude down. If the whole length is 11, then this would be 5.5, 5.5. So I have a right triangle right here. notice that a right triangle. And I'm looking for the altitude, we'll call that x. So once again, tangent of 27 degrees equals opposite over adjacent. Multiply both sides by 5.5. And there we go. 5.5 tangent of 27 degrees will give us 2.8. So the altitude is 2.8. Okay, guys? Alright. I hope this review sheet help video has been a help to you. If you have any questions at all, please never hesitate to